It's very nice to speak here. It's my first speech. And normally I do a speech on the daily about the technical stuff, but here is more people than on daily. Nice. Okay. So maybe we can start now. Let's check if it works. Yeah, it works. First thing, nice. So who I am? I'm full stack software engineer at Wave. On my free time, I'm moving from the websites, e-commerce, and blogs from old CMSs to Payload CMS. I also own a 3D print farm, and I'm pioneer of the new movement against the vibe coding. It's called craft coding. It's funny because I run the Cursor Jam session also, but you know, I go to the two fronts. Oh, yeah. Okay, I should stand here because I always forgot about that. Thank you. Yeah, I do not forget. Yes, and as the presentation is about QR code, there is a first QR code. This QR code provides you to the Slido, and here you can ask a questions because if you are shy, and also on the end there is a quiz, and if someone win, for sure someone will win. For the winner, there is a small stuff. It's a dino from Google when you don't have the Wi-Fi or the internet. So I hope it find the new owner. Okay, let's start. So today, I will try to show you how the QR code is built, not the scanner way, but the build process from the word, which we want to encode, show, and allow to scan for the scanners. So to make the presentation more easy to understand, our word will be JS. So creative. So first step is data analysis. Here, we have to choose what type of our data in the QR code will be. So we have the numeric type. We can choose the byte type, alphanumeric, and kanji. In the numeric, there are digits from 0 to 9. In alphanumeric, there are digits from 0 to 9, uppercase letters A to Z, and symbols. And that's all symbols because there is a special table where all available characters are, and they have special number, which will be important later. Then we have normal byte mode. Here we have ISO characters and UTF-8. And on the end, there is a Japanese character in kanji mode. As we have just word JS, we will save it in alphanumeric. Then QR codes have something like error correction level. This is more interesting. Here we have to choose how much data we want to recover when the QR code is scratched or missed, or when you run with your phone and try to scan the QR code because you want to go to the metro, to subway, and it's still able to scan it. And everything is thanks to error corrections codes, which will be later, but now we have 4 levels of them. And here is how much data we can still recover based on the level which we choose. Of course, higher version, cut some data which you can save into actually the data matrix, the QR code. So for our case, we have just JS word. We can be with the age level. Then we have to choose the version of QR code. So the version, it means the size and how much data we can save into QR code. Version goes from version 1 to version 30. In version 1, we can save up to 25 characters in alphanumeric mode. In byte mode, that's just 17. And all is in the error correction level L. So even when we have the age, we can save less data. And in version 40, we can save up to 7,000 characters in numeric mode and on the other modes. Yes, so for our purpose, there is version 1 more than enough. So wrap up, we know that we have JS word. We know that our data type is alphanumeric. Our version of query code is 1, and the error correction level is H. Nice. Now we have to encode our data because, as you maybe mentioned, as you maybe know, the data inside the query code is a bit string, so there is zeros and ones only, where 0 means white space, 1 means black space. So before we start actually encode the data, we have to add something called mode indicator. We also have to add character count indicator. Then we encode the data. And on the end, we add the code words and paths. But firstly, what's a mode indicator? So here we add at the beginning of our bit string, we have to add the code which say what type of query code it is, like what type of data it is. In our case is 00010. Then we provide the character count indicator. And it's most complex because here that depends on the version of query code. And here I prepare example of Hello World. So in Hello World, for example, we choose version 1. And we have here alphanumeric. I don't know why, but let's say, alphanumeric because there are words. And in version 9, our bit string has 9 bits length, and we have to, in byte mode, provide the number. So here is 11. And in our case, when we have just 2 words, there is in byte mode our information, and this is our character code indicator. Now we are finally able to encode the data. So encoding is different for each type. In numeric mode, we group our digits in 3 length groups. Then we convert them to the number, and from decimal, we put them into byte mode. But also, every of it has 10 bits. For our alphanumeric mode, which is our mode, here we take the whole formula, whole text, we split it to two pairs, and each pair has 11 bits length. And here's the formula. We take the first letter, and we can take the number from the table which I said before. Then we multiply it by 45, and we add the second letter. And we got the number, and we convert the number decimal to byte mode. In our case, it's this. And also there is a different for byte mode, and there is also for kanji mode. So there are different approaches. And now we have something called code words and paths. So basically in the query code, you cannot have some space not fill it. So the code query have to be full fill in. And for that, we have 3 things. We have terminator, path, and remaining space paths. So terminator is used to fill in the query code when they're just left like 2 spaces, 1 space, or 3 spaces. But in our case, when we have just JS word and there is still a lot of space, we will add 4 of them. Okay, maybe there will be better. So here is the terminator. Then we have something like path strings. Here it is. So we use these paths, the additional block of zeros, to make sure that our data string is dividable by 8. If it is not, we have to add as much as is needed. And on the end, we add something called remaining space paths. And we do it in rotation way. So first we add the first path, second, first, second, first, second, first, until we fill in the remaining space. And this is our data, actually how it looks like after the encoding process. Nice. So wrap up. So I don't have to do wrap up, but for everyone. And now what is still missing? So our error correction codes. So here it will be very simple, the process of that, because it's more complex, and behind of that there is deep math. But for this presentation, just simple steps. First, we have our message, which is JS. Then we create the polynomial, and here is the driving session. And for example, we have such a function, and I know that 0 is not here, but for the presentation, I will put it here. And we have word S, and yes, and based on these two values, we create the polynomial. Then we give extra symbols, extra values. So one will be here, M, and one will be here, it's K. Great. And then we, yes, and then we have the code word JMSK. But how actually it works? So let's say we miss the S value from the query code. The scanner is not able to scan it. And now, thanks that we have additional values, additional characters, now the scanner could recreate this polynomial and put the value again on this function. And thanks to that, the function is recreated. It can again read the values. Okay. I would say, like, I want to say it. So under the hood, there is the Fourier equation, and there is Gauss fields, which works at that. And if someone is here a math geek, they could think that there is a Lagrange interpolation, but it works in different way. But it's very, very similar. Yeah. So now we have our blocks of data. We know how the process of error correction code creating works. So now is the time to structure the final message. But structuring the final message is also not that simple as we can think. Firstly, we create block division. And block division depends on the version of query code, but the simple meaning is that we take our message, which is say data, and we split it to the blocks. Then we create the error correction codes, but we create them for blocks, not for whole data. So we got the block first, and we create error correction first. Then we have block second, and create second error correction codes, and as far. And then no. So now there is a last step. We put everything together. Yes, and also it's not that way how we create error correction codes. We have to again put them in correct order. So we put firstly data, and then we put the error correction codes. And now there is a little image, but please don't read everything here. Just focus on this space. So as I said before, here we have the information about the data and the character length. Then we put our words and actually data. And on the end, we put the error correction codes. And now I create a little app here to show you nice patterns, modules, and how data is placed. There are not. Okay, I will back there. Don't worry. It's on the production, so let's hope that it don't break, and there is no tests. Yeah, but make it bigger. Yeah, there is a blank query code. So this is my favorite part of the presentation. Firstly, we will put the pattern, which is a finder pattern. And this is on every query code, and it helps a scanner to know in what orientation the query code is. Then we are adding something called timing pattern. And it's also on every code query. And it helps scanner to actually calculate what the size of query code is, because version information, which we actually add to the query code, and we will add it, it's not on all query codes. And if you have a small one, like our one, it's version 1, it has only these timing patterns. And based on that, the query code know how big it is. And actually, it know how the pixel is big. So yeah, there's a lot of thing after behind this pattern. We have version information, format information here. So in these 3 places, so here I think is the type, there is the information about error correction level, and on that corner I have this thing here. On this place there is both of these values. Now we add the version information, and it is here because this QR code is in version 10. So, but in the lowest ones there wouldn't be here, but there is information about the version. Yeah. And now we add something called align patterns, and the goal of this pattern is to make scanner able to read QR code from the engine. So if you are, in the funny place and you scan it from there, it will help scanner to read it. And now there is a last tiny guy, which is here, is the dark module, and this dark module allows scanner to understand if the QR code structure is well read. Because if it, yeah, this is how it works, and I don't actually know how it will work if you will mess this point. I think the scanner can go crazy. So if you want to, destroy QR code, but you don't want to make it replace it just displays, and probably it will be make like the small scanners can have the problem. And if you run and this QR code is from far away from you, the scanner could have problem with scan it. Yeah, and now let's place our data, because we have all patterns, we have all modules. This is all what it is. This is funny because it's every QR code it has, everyone. Yes, and now I will place the sample of how data is placed. It's go like zigzag. In this way is put it. So let's add the real data. Oh, it goes. Yes. Can someone scan if it works? Here should be hi word. No, there is no JS. There is no JS. There is hi. It's like, this is production. I don't. It works. Maybe because of color. Okay. Okay. Maybe this one really works. Yeah. Okay. The colors was the problem. Yes. Okay. Do we have something like I want to try if we can remove this guy and check if it's still possible to read it. Okay, but to read. Oh, on the MacBook. Oh, no, I don't know how to do it. Yeah. Okay. So let's try. From this one? No, we have to. Yeah. Maybe I would. Oh, yeah. Or you can click the switch here. So give me a second. Maybe we can click this to make it red. Oh. Let's try. Works? Oh, because we have good scanner. That's all. That's. Oh. Okay, but it shouldn't. So you have good scanners. Okay. Yeah. Well, but that's how the QR code patterns looks. Yeah. But as you may think, it's end, but it's not end. There is one last topic. There is data masking. The goal of data masking is to make sure that there are no any patterns that shouldn't be there. So like you see the timing pattern there, that just the dots, white, black, black. It can happen when you put the data. So the masking is for this, is created for this. The masking works as a XOR operation. The XOR operation is like you get the original data, you have the mask, and if you have two same values, you got O. If you have two different, you get 1. There is 8 masks, which the QR code standard have. And you apply all of them to your QR code, and then you calculate the penalty. So there is also something, it's called penalty rules. There are 4 rules, which you have to, maybe you don't have to, you can always apply the first one, but this is, this is in the documentation, they say, oh, use all these 4 rules and that will be fine. But, I also do this, like I put the first mask and, let's go. But here it go. So first penalty is go if there is penalize the presence of 2x2 blocks of the same color. Sorry, I read the next penalty rule. Penalize long sequences of the same color. So if you have 5 color in the row of the same color, you get 3 points and additional 1 for each next. And now you penalize the presence of two blocks of the same color, and you get extra 3 points. And as I don't mention, but if some mask got the have the less points, it's win. Yeah, because if you have more, you are worse. Yeah, and now if there is any pattern that is like a module, so like timing module, like the finder pattern, like the others, you get extra 40 points. So this is like you lose. And now there is last one, and it's just calculate the balance of white and black and dark modules. And it's but if there is the good balance, it got 0 points. If there is a worse balance, it's got 7 points. Yeah, and that's all, but not all.
Oops.
There are some questions in here.
Yeah. So you wanna respond to some of them, I guess. And you can also pick your favorite one. At the end.
Okay, yeah, I see there is one. Oh, it's from Piotr. It's from you.
No, Piotr wanted this one.
Okay, that's a very interesting question. If okay, I maybe put it there. Okay, if barcodes are 1 dimension, QR codes are 2 dimension, what's stopping us from making 3-dimension codes? Imagination, I think. I don't know, maybe there exists something, but I think that could be hard for scanner. But if you will go to the 4th dimension, you are able to see the 3D dimension code from all sides. So yeah, in the 1st dimension, it will be possible. Oscar asks, what about company logo inside QR code? How does that work? It uses the error correction levels. So just miss the data, and that's all. Or there are some standards, but for that you have to have your own scanner. And there are some bit matrix, the old one, which are now on the Orlen Paczka, if someone use it. There is a funny QR code which have the one corner full of black, and the rest of the space is like white and black. They're like QR code, but there is no align patterns and no this stuff. So yeah, I forgot what was my point, but yeah, I talked something about those. And last one, why the mode takes 4 bits while it could take only 2 on 2? Okay, I understood. That was there was okay. I remember what was that. Mode indicator. No, there is. Oh, this one, yeah, the red one. Oh, here. That's I think this is for the QR codes. I think so. That's a good question. I don't know. Sorry, really, I don't know why is that. But that's a very good question. I think it's that because there is ones on the. That's very good. I will check it out. Maybe. Like I know that I remember why I talk about the bit matrix, but yeah, so companies can create own scanners because it's like this is open source set and you can create this QR code as you want. So maybe there is a space for making scanners to understand that this mode is mode from the company. Maybe that's why. Okay.
Yeah. That's pretty good. I think we are okay. Here's the question: do you want to have him answer more questions, which is very nice, or you want to have pizza faster?
No, well, that's not fair.
I understand.
That's not fair.
I understand.
That's
This is not fair. But we are in a democracy here, sort of thing. So
No. Okay, don't do it. Don't do it. It's like
no. Do you want? If it's really fast, you can do it, right? Like a speed run.
the question?
No, if you want
from-
to. If
I
you want
think-
to, yeah.
I think we can ask someone. No, people won't.
There are some questions of this.
There are
too,
some
right?
questions.
So you have 10 seconds per question. Let's go.
Do you create the slide QR code yourself? The slides, no, the slides I made with the slides.com, but yes. Sorry? No.
Next one. Next one.
Why are we alive? Oh no, that's type of question. Because someone have to create a beer. What was the weirdest thing that you encode? Oh yeah, I know. When I was on the university, there was
Next one. No time. Sorry, we are speed running here. 10 seconds.
Yeah. But funny that I was forced to encode in which group I am. So yeah, that was the first test. So for the first question in the exam, choose your group, and if you choose wrong one, you'll don't pass. Yeah, funny thing.
Okay, that was pretty good. Anyway, so please give a big hand to Kacper.
Thank you.
That was amazing, man. That was your first talk. That's incredible.
Warsaw.